it also knows that if you call a getter for that slot, that the object has a type number, uses that for optimistic type inferencing. I have a default value, which is 0. And then there's an init keyword. If I create an instance of a square, and usually a square is, an object is instantiated by calling the function make, I can pass an init keyword x or y and specify a number there. And there's also another slot, and you see it also has a keyword, but it's got a required init keyword. What that means is that if you don't pass that init keyword and don't pass a value for that slot, then the system will refuse to create an instance of the object. So basically what you defined here is if you create a square, you can pass an x and a y coordinate for placing the square, but you have to pass a slot, pass a width, which must be a number. One of the slots is constant, which means that no setter is generated. You can only set the object on instance creation. And that's also something the optimizer uses. So in this case, it knows that slots x and y are initialized. They're initialized to 0. So the slot cannot be uninitialized. So you don't have to include a check when accessing the slot of that object if it's initialized or not, because it always is. The same for the required init keyword. And also knows that this width slot is constant and can use that information for moving around expressions in your code for optimization, pulling stuff out of loops, etc., etc. I already mentioned keyword arguments. Here is an example of a function which has a keyword argument. So the function describe list, you always have to pass it my list, but optionally you can pass it a keyword argument verbose question mark. So you can say describe list, some list, and then verbose question mark colon true. And then the code is executed, but you can leave it away. So that's a way for having optional arguments. Again, in C++, you can give default values to function arguments, but you have the restriction that you can only leave away the last argument. So if you have two optional function arguments in a C++ function, you only want to pass the second one. You cannot do that because you have to pass the first one before, and you have more flexibility with those keyword arguments. Yeah, higher order functions. I already mentioned that functions are first-class types in Dylan, and higher order functions are functions operating on functions. And this usually allows to write very compact, very efficient code. Anonymous functions are one feature. You don't have to name a function, but you can create a function on the fly using the method statement. So the function on top is actually a function returning a function. If you look at the function body, it returns a function which does a little computation and accepts an argument x. And what you also see here is a concept called a closure, which is basically you create an anonymous function, and that anonymous function refers to other information, and basically the method makes a copy of that information and puts it into the function as well. So it's more powerful than a function pointer because it's basically a function pointer with additional attached data. So for instance here in that, the make linear mapper function takes two arguments, times and plus. And those are referenced inside the anonymous function that's generated there. And every time you call make linear mapper, it creates a new function, returns basically a pointer. There aren't really pointers in Dylan, but it returns a pointer to the newly created function, which remembers the values of times and plus. So you can execute the code, which you see in the bottom here. the defined constant times 2 plus 1 calls the make linear mapper function, and so the constant has a value of a function that takes one argument. You can call that, pass 5, and get the desired result. This is very, very useful for creating stuff like callbacks in a user interface. You have a graphical user interface, the user presses a button, and the moment the button is pressed, some callback is called. What you often see is in, say, C, that the user can set a callback, and then there's an additional data parameter, which is passed to the function that the user has specified. And then you can stuff all kinds of data for doing the work into that one single data pointer. And what you usually do is create a structure and then cast it to a void pointer and put it in there. And when you pull it out back, you cast it back to the function you expected there is. But that's not very convenient, and it's basically not type safe. At the moment you start doing conversions to void pointer and back, you risk making a mistake, and that means risking a crash. So a closure is a type safe way to do the same thing, to basically pass arbitrary arguments to your callback function you create on the fly. It's the function class, it doesn't have a public interface. If you look at it from the inside, you'll see that a function has a number of entry points, which are basically code addresses. Usually you have interior and exterior function entries, which do type checks or do not type checks, and the compiler can leave away the type checks if it can prove it's safe. You usually have a subclass of function for closures, which then references the list of variables you referenced to get at the data. So, but it's nothing you ever see as a programmer. It's just behind the scenes. There are other convenient functions that, something you should mention, if you have ever used Lisp, you'll know lambda expressions. And basically, what's called lambda in Lisp is called method here. It's the very same thing, just a different name. And the Lisp people call it lambda because of the lambda calculus. And in Dylan, they decided that most programmers instinctively know what an anonymous method is, but have never heard in their life about lambda, so they changed the name. You can do other interesting things. Curry, for instance, takes a function and an argument and returns a function where that single argument is already on the list. So you can say curry von plus and 1, and that's an increment function because plus takes 2 arguments. If you say curry from plus and 1, one of the arguments is already put into the closure basically. Reduce can be used to operate on a list and basically call the same function for every element in the list in succession. Map does something very similar, which calls a function for a list, for several lists of arguments. So it takes the first argument and takes the first element from all the lists and passes it to the function and then to the second one. And so instead of writing 5 lines of a for loop or something, you usually get around with just a reduce and a curry and maybe an anonymous method to do a lot of things.
And you don't have to think of off by 1 errors in loops, because you simply use map and don't have to count the size of the list. Yeah,
it's less typing, less opportunities to make errors, etc., etc. Yeah. You can call C functions pretty easily. That's how it is done. You import a header file. That's not standard Dylan, but it's something that works. Generic functions. It's that's what I mentioned when talking about multiple dispatch. That Dylan separates the idea of classes from the idea of functions, and a generic function is basically a collection of so-called methods for certain sets of parameters. So that's a very simple example because you only have one parameter that's passed to the method double. Can either be a string or a number. And depending on whether I pass a string or a number to a function called double, one of the two methods is called. That isn't more powerful than the other approach yet, with one difference. I don't have to think about all the functions I could possibly want to call when writing down the class definition. So as a user of some library, I can write my own generic functions operating on somebody else's classes without having to change his class definitions. But the real power is when you pass multiple arguments to a function, and the right method is selected by looking at all the arguments that are passed to the function. So in that example, we have a inheritance structure for vehicles which knows about cars and trucks. And I have inspectors and I have state inspectors. What happens is that when I call a generic function, it chooses the most specific methods. That means that method which most closely resembles what I actually passed to the function. The next method calls the less specific method. So in that instance here, the most generic case is a vehicle and an inspector. And if the vehicle is a car, it first calls next method and then additionally performs additional checks. And the same for trucks. And you see that you can basically write down a method for all possible permutations of arguments passed to that function. So the usual explanation why that is useful is when thinking about the sex function and male and female objects. When you start thinking whether sex is a function of male or a function of female, which then gets passed the other one as an argument, you start to realize that doesn't make sense at all. And you also start to realize that make love of man and woman is something entirely different than make love from man and a man, and that again is entirely different from make love from a woman and a woman. And so the whole concept of the way object-oriented programs are written in C++ or in Smalltalk, it just isn't powerful enough to express all the ideas we have about how things work in real life.
There's a question. The order in which the next method calls are executed, is it well defined, or is it just by accident? Or
Yes, due to the superclass linearization, you have a single list which type is more specific than another type of a class. So the next method calls the next specific methods. There are corner cases when you have two arguments and both are equally far away from the actual type.
if you had a method inspect vehicle which would take a truck argument and a state inspector, and we would run the next method at first, would it call the inspect vehicle on the car and the state inspector, or on the truck and the inspector? Or is it by chance, or is it it's possible to define an order, but Dylan takes the default order?
It's not by chance, it's well defined. There's a linearization algorithm which is specified for which defines the order. But basically, this is such a corner case that it's probably not a good idea to rely on any specific ordering in that case. So it's better to use it if you really know what's going on, instead of, or if you don't care whether the one or the other one is called first. So in that example, for instance, it doesn't make a difference whether the seatbelts are checked first or the cargo attachment is checked first. It's the same, but it's well defined. Okay. That I already mentioned in the optimistic type inferencing. So in the first line, let defines a variable. So let C equals A plus B defines a binding C. and assigns it. And I can leave away the type because it's dynamically typed, and the value that's computed on the right-hand side is what has a type. But I can optionally specify